with precise taping on sloping ground. The topics that we'll cover in this video include the problem of taping on sloping ground, the solution to taping on sloping ground, and a field illustration of taping on sloping ground. The problem with taping on sloping ground is the following. If we tape along a slope, it can be difficult or impossible when the tape cannot be held horizontal without plumbing above the chest. In an illustration, we have sloping ground where we're trying to measure our distance from point A to point B. The direction of survey is almost always downhill to facilitate the process. We plumb our tape and hold it horizontal, and we always have the 100-foot end at the uphill end and the 0-foot end at the downhill end. The problem then becomes the plumb line at the 0-foot end is greater than 4 to 5 feet, thus making it impossible to plumb above the chest. The solution to the problem is breaking tape. What we do is we take the tape and we measure the distance in short successive segments. The first segment from the 100-foot mark to a convenient full mark along the tape. In profile view illustration, we can see in the sketch that what's happened here is the tape has been left laying on the ground from some convenient point in the tape to the 0-foot end, where we've plumbed from the 100-foot end over to a full foot mark on the ground, where it's convenient to have a plumb line of 3 to 4 feet of height. This is what's called breaking tape to a full foot mark. In this particular illustration, the head tape person has walked down the slope to a convenient point, and the point in this particular illustration turned out to be 73 feet. So at 73 feet, the head tape person will plumb a line and stick a chaining pin in the ground as a reference point for the head tape person to measure from in the next successive segment. The second segment is from the 73-foot mark to the next convenient full foot mark along the tape, and we let the tape do the addition. So in this particular situation, the rear tape person comes forward, lifts the tape up off the ground at the 73-foot mark, plumbs it. The head tape person walks forward to another convenient spot where plumbing can occur, where this plumb line is somewhere between 3 to 4 feet, so that the head tape person can plumb about chest height or belt height, somewhere in there, something convenient. And in this particular illustration, we have a second break mark at another point along the tape, a convenient location. Here, this turns out to be 38 feet. So the head tape person plumbs the 38-foot mark over a point on the ground, marks that point on the ground, and puts the chaining pin in the ground there as a reference for the rear tape person when the rear tape person moves forward. Everyone lays the tape down. The rear tape person moves forward to the head tape person's 38-foot spot, and the head tape person moves forward to another convenient location down along the tape. The third segment is, in this particular example, is the final segment where we measure from the 38-foot mark to the end of the tape. In our sketch, what happens here is the rear tape person picks up the tape at 38, and the head tape person moves forward along the line to a convenient point where the tape can be plumbed. In this particular case, the head tape person can walk clear to the 0-foot end, plumb the line, and mark point on the ground, and that would be the 0-foot mark. So you can see in this example that the tape has been left to lay along the ground as we make the measurement. So the tape actually makes addition as we measure the line along the ground. And so we know then that the distance between point A and point B is 100.00 feet. Our summary solution then is we look at all three segments equals to 100 feet. Here is a segment that is 27 feet long from 100 to 73 feet. The next segment is from 73 to 38. And then the last segment is 38 feet from 38 down to 0. Breaking tape in two spots at the 73-foot mark and then again at the 38-foot mark to get our sum distance of 100 feet. A field illustration of this, as we can see here, is the rear tape person, and the rear tape person is holding directly on the monument since the ground slope is such that the unsupported tape length does not touch the ground. So instead of plumbing, he is marking right on the point on the ground, which is very convenient. It's much easier to make a hold without a plumb bob. The head tape person is plumbing the line, and you can see the plumb bob right here, and applying attention. You can see a tape clamp right here, and he's applying attention on the tape. You can see the chaining pins he has right here, ready to stick the chaining pin in the ground to mark this even foot mark on the tape itself. Tape again is fully unsupported and does not touch the ground anywhere. This is breaking tape for one segment. In summary, what we've talked about then is we've talked about the problem of precise taping on a slope. We've presented the solution to precise taping on a slope by the method of breaking tape. What we hope you could come away with from this learning video is the following: that you understand the concept of breaking tape for horizontal measurement on sloping ground. This ends the video lesson.